Ethological findings have shown that insects, like honeybees, can freely fly based on optic flow cues and perform complex navigation tasks. Behavioral studies on flying insects have helped us to develop innovative solutions for the visual guidance of aerial vehicles on the basis of optic flow. We present in this video a custom-made free-flying sighted hovercraft named LoRa, embedding its own energy, its own optic flow sensors, and a vision-based autopilot, allowing the robot to control both its position and speed in a corridor on the basis of optic flow. Several feedback loops are implemented on the robot. A heading lock system equips the robot to compensate for any yaw disturbance. The LoRa-free autopilot is based on the dual optic flow regulation with two optic flow setpoints, omega forward and omega side, that allows the air vehicle to travel along a corridor by automatically controlling its speed and its clearance from the walls. The forward controller, the blue feedback loop, adjusts the forward thrust on the basis of the sum of the right and left optic flows, whereas the side controller, the red feedback loop, adjusts the lateral thrust on the basis of whichever of the two lateral optic flow measured is the larger. The free-flying hovercraft is fully actuated by means of 4 ducted fans that drive it into the plane. An additional lift fan is used to inflate or deflate the skirt to make the robot accelerate, slow down, or brake. A main electronic board composed of 3 microcontrollers is in charge of the visual and inertial signal processing that feeds the autopilot. The 4 eyes are facing in different directions and measure the optic flow generated by the hovercraft's own motion. Only lateral optic flow sensors facing at plus or minus 90 degrees are used to feed the autopilot with the visual signals. An optic flow sensor consists of an optical assembly composed of a lens and a pair of photosensors driving a bio-inspired EMD circuit running the time of travel scheme to measure visual motion. On this video sequence, the heading lock system is not implemented. As we can see in the video, the robot tries to follow a single wall, but it is not able to navigate safely in the corridor without clashing on the walls. From now on, the heading lock system and the dual optic flow regulator are implemented in the robot. These videos show us that the LoRa-free autopilot, based on the dual optic flow regulation principle, enables the hovercraft to perform various tasks such as wall following and centering without having to switch abruptly from one behavior to the other. All these results show us that whether the robot will follow a wall or rather center depends purely on the corridor and on the 2 optic flow setpoints.